So there are another operators, forward operator, this is your delta symbol, and here we have another operator, backward operator, and this one is your Nabila symbol. I start with the forward operator, which is your delta symbol. Let I take the y is equals to f of x. If I apply the delta on fy, that means delta of f of x. Delta of f of x is f of x plus h minus f of x. The definition of forward operator is delta of f of x is this is the difference between f of x plus h minus f of x. I explain this definition with the table. So for that I need some x and corresponding y value, and y is equals to f of x. As we know that I take finite value of x, there is corresponding finite value of y. For x I have x0, x1, x2, x3 and x4. Right? You can calculate this x1, x2, x3, x4 value with the x0 plus h. H is what? It's an increment in previous value. You can get x2 with the 2 increment at the x0 position, and here similarly x0 plus 3h, and this one is x0 plus 4h. Or you may write this value is x1 plus h. So you can easily construct the value of x, and this x value is known as an argument. Of the table. And y is equals to f of x, it's the entry or function of the table. If I have x0, the corresponding value of y is given by y0. This one is y1. Here I get y2, y3 and y4. With this definition, delta of f of x equals to f of x plus h minus f of x. If I initialize this x value with x0, so my definition is f of x0 equals to f of x0 plus h minus f of x0. F of x0 is what? F of x0 is y0. So delta of y0 by the definition, this is x0 plus h. That means f of x1 minus f of x0. F of x1 is denoted by y1 minus y0. So what is the delta of y0? Delta of y0 is a difference between y1 minus y0 value. So if I start the column with the first difference, that means the first delta of y, I get the y1 minus y0, because this value is a difference between these two. So this value is denoted between these two value is given by delta of y0. If I want to complete the column, my next step is y2 minus y1. Definitely difference between these two value. What I get? Delta of y1. Succeeding minus preceding value is always give the value of difference of preceding. Again y3 minus y2, it's give the delta of y2, and y4 minus y3 is give the delta of y3. So I complete my first column, which is my first difference of the yth table. If I get the second order of the delta, this is denoted by delta of y. For the second order of the delta, my definition is quite different, or here I solve the entire definition for delta raised to power 2. So delta square of f of x is what? It's nothing It's delta of f of x. Delta of f of x with the previous definition is f of x plus h minus f of x. Here I apply the distributive law. I apply the delta on f of x separately minus delta of f of x. Now I apply the delta definition on f of x plus h. It's give the f of x plus h minus f of x plus h minus f of x plus h minus f of x by the definition. This is f of x plus 2h minus twice of f of x plus h plus f of x. This is my delta square f of x. This is delta square f of x. See, in this rectangular box, I explain the delta square f of x is delta of f of x plus h minus delta of f of x. I initialize this x value with the not position, so this rectangular box convert into delta square of y1 equals to delta of y1 minus delta of y0. Because x0 plus h is x1, f of x1 is y1 by the definition. So basically delta square of y1 is what? It's a difference between the first column value is delta of y1 minus delta of y0, which is delta square of y0. This is delta of y2 minus delta of y1 is delta square of y1, and here delta of y3 minus delta of y2, it's give the delta square of y2. This is for the second order. And this table will be terminate at if I have n argument. If I have n value of x, the table will be terminate at delta raised to power n minus 1. So for this table, I have 1, 2, 3, 4, 5 value. So argument value is 5 and the last column value of difference is 5 minus 1, that is delta raised to power 4. Okay. So here we have two more column in our table, delta raised to power 3 of 5 and delta raised to power 4 of 5. And delta raised to power at delta raised to power 4 of 5, my table will be terminate. For delta cube of y is again the difference between these two values. It can be write delta 2 y1 minus delta 2 y0. It's give the delta cube of y0. For this, delta square of y2 minus delta square of y1, it's give delta cube of y1. And the last column is delta cube, because this is again the difference between these two values. It's come delta cube of y1 minus delta cube of y0, which give the delta raised to power 4 of y0. So here, for the forward difference operator, I start with the y0 value till I get the delta raised to power 4 of y0. So this is your forward operator table, and this table is known as a forward difference table. Right? Now we come to a backward operator. For the backward operator, the definition for the backward operator, this symbol is known as a nabela. Let my function is y is equals to f of x. I apply the backward operator on y. This is nabela of f of x. It's give f of x minus f of x minus h. This is the definition of nabela. If I want to initialize this value with x naught, but I don't have such a value with x naught minus h in my table, so every time I initialize this value with the first position for the backward shift operator as well as for the backward operator nabela. So for the nabela f of x1, it's give the f of x1 minus f of x1 minus h. That means nabela of y1 is the y1 minus y0. If I explain this definition with the table, again I have to write the x value, x column as well as y column. X naught, x are the argument and y is our definition, the function definition. So I take only 2 or 3 arguments. Similarly, the corresponding value of y is y0, this one is y1, y2 and y3. And the first backward difference, which is denoted by nabela of y. Nabela of y is what? Because here succeeding minus preceding value y1 minus y0 is always denoted by nabela of y1. y2 minus y1 is always denoted by nabela of y2. The difference between these two value is always denoted by y2. Similarly, y3 minus y2 is denoted by nabela of y3. And the second order of nabela is again nabela of f of x square is what? It's nabela of f of x. Nabela, I open this nabela f of x with the definition is f of x minus f of x minus h. I distribute this nabela with the distributed law on the every function. I get nabela of f of x minus nabela of f of x minus h. So nabela square of f of x is a nabela of f of x minus nabela of f of x minus h. For every nabela or for every backward operator, every time we have to initialize this x value with the 1. So when I initialize this x with the 1, what I get? I get nabela square of y1 equals to nabela of y1 minus nabela of y0. So for the second order, for the second column, the difference between nabela of y2 minus nabela of y1 is always give the nabela square of y1. Nabela square of y2. Nabela of y3 minus nabela of y2, it's always give the nabela square of y3. And the last column is nabela cube of y. It's nothing, it is difference between two quadratic value like nabela cube of y3 minus nabela square of y2. It's give the nabela cube of y3. See, in the forward difference table, we start with the y0 point and we get the y0 value. But for the backward difference table, we still start with the y0, but we get the nth value of y. So this is the basic difference between forward and backward difference operator as well as forward and backward difference table. Thank you.